Okay, this is our third differentiation lesson. First we learned the basic rules, which are we multiply by the power and reduce the power by 1. We also learned that sometimes we need to do a bit of preparation before we differentiate. We don't like x to be on the denominator of a fraction, and we don't like it to be under a root. We use our inverse rules to convert these expressions to something that we can differentiate. Today we're going to look at some functions which are slightly more complicated, and again we're just going to be looking at how we can put them in a form where we can differentiate them. I just want to look at a pattern first of all. Here I've got a function where f of x is equal to 3x squared. So we're just going to follow the basic rules. To differentiate, we're going to multiply by the power, so 2 times 3 is 6, and reduce the power by 1. 2 less 1 is 1. Now, when we've got a power of 1, we don't generally have to draw it. So we would just differentiate that to 6x. Second example here, I've got a function equal to 3x. So to differentiate, I'm going to multiply by the power. Now there's no power there. If there's no power written, it means it's a power of 1. So that's going to be 1 times 3, which is 3. And then reduce the power by 1. Well, 1 less than 1 is 0. So it would be 3 times x to the power of 0. But x to the power of 0 is equal to 1. So this means that it will just be 3. In this example, the second example, the derivative is a constant, so that means it's always going to be 3 regardless of what x is. That means our gradient is always going to be the same. And that's because this function here, f of x is equal to 3x, is a linear function. It's a straight line. So the gradient will be the same all through the function. For the third example, f of x is equal to 3 and there are no x's at all. But since x to the power of 0 is equal to 1, we can consider that to be the same as 3 times x to the power of 0. Now when I multiply by the power, I'm going to be multiplying by 0, which is going to give me an answer of 0, always. So if the function is a constant term, the derivative is always going to be 0. Now before we go on, I just want to remind us of a few inverse rules. If you're not confident with these, please go ahead and do the essential exercises. Get yourself back up to speed with inverse rules. X to the power of 0 is always equal to 1. Anything to the power of 0 is equal to 1. X cubed multiplied by x squared is x to the power of 5. And the general rule for that is we add the powers when we're multiplying. X to the power of 5 over x to the power of 2 is equal to x to the power of 3. And the general rule when we're dividing indices with the same base number is we subtract the powers. We're going to be using these inverse rules a lot while we're differentiating, so please make sure that you're up to speed with all the rules. Now our functions can get as complicated as they like, as long as it's a list of functions which are added together, so a sum, in this case 3x cubed, negative 2x squared, plus 5x. I can just differentiate each term individually. If it's not in this form, I need to make it in this form. So the first example here, I'm just going to differentiate each term in turn by multiplying by the power and reducing the power by 1. So 3 times 3 is 9, x squared, because I'm reducing the power by 1, minus 4x, reducing power by 1 gives 1, so I'm not going to write it, plus 5. That's a constant because remember x is to the power of 1 and then when I reduce it, it's x to the power of 0. In the second example, I'm going to use slightly different notation. We're going to have a lesson about this later. But at the moment, because we were given the function in the form y equals, rather than in function notation, I'm going to give my derivative as dy by dx. We'll talk more about this in a different lesson. Multiply by the power, reduce the power by 1. 4 times 2 is 8. Reduce the power by 1, it's 8x cubed. 3 times negative 4 is negative 12x. Reduce the power by 1 squared. 2 times 3 is 6. Reduce the power by 1 is 1. 6 times 1 is 6. Reduce the power by 1 is 0. The 2 just disappears because remember it's x to the power of 0, multiply by 0 makes it 0. So a key point for you today is that any constant terms in the original function will disappear in the derivative. They will be equal to 0. These examples are from your notes on page 4. We're now moving on to page 5. Okay, on page 5, we're given a function y equals 1 over 3x multiplied by the square root of x. We've got x's on the bottom of a denominator of a fraction, we've got x's under a root. We need to sort all these things out, so we're going to do it step by step before we differentiate. Instead of saying 3x times the square root of x, I'm going to say 3x times x to the power of a half. That gets rid of the square root. I'm going to remind myself that that x is to the power of 1. Now I'm going to use my index rules to push these x's together. So I've got x to the power of 1 multiplied by x to the power of a half. When we multiply indices, the rule is that we add the powers. So I've got 2 halves here plus 1 half here, so I've got 3 halves. So this is the same as 1 over 3 times x to the power of 3 halves. I don't want the x to be on the bottom of the fraction, so in order to bring it up, I'm going to leave the third where it is. The 1 and the 3 are not moving anywhere. I'm going to bring the x up and I'm going to put negative 3 halves from the index rule that we learned about in the last lesson. Now at this stage, you feel like you've done quite a lot of work. Don't forget we haven't yet differentiated. That was just to get us to a point where we can differentiate. So now we'll go on. I'm going to say that I'm differentiating using dy by dx. I'm going to multiply by the power. So I've got negative 3 halves times 1/3, which is negative a half. Reducing the power by 1, well I've got negative 3 halves. If I take away 2 halves, that's negative 5 halves. If at this stage you're not confident with fractions, just check what I've got in the bubble here, where I got the negative a half from, and go back and use the links that I put in the team's notebook for you to do some practice with fractions. Now I've done the differentiation, but I want to tidy it up. I don't want any negative or fractional indices, so I'm going to use my index rules to move the x. The negative part tells me that if I move it down here, I can make it positive. The denominator is the order of the root, and the numerator is the power. So this is the same as negative 1 over 2 times the square root of x to the power of 5. Okay, example 2. Here we're told that y equals x minus 3x plus 2. We're given an expression here in a factorised form. In order to differentiate, we do not want it in a factorised form. We want a sum, not a product. So that means we need to multiply out the brackets, which means I'm going to get x squared plus 2x minus 3x minus 6, which is x squared minus x minus 6. Now I can differentiate. Dy by dx is equal to, and I'll just differentiate each term. So x squared differentiates to 2x, negative x differentiates to negative 1. The negative 6 is a constant, and so that disappears, or it differentiates to 0. Example number 3. We're told here the function of x is equal to x over 5 plus 1 over x squared. Now, this is a sum, but there's an x squared on the denominator, so we're going to deal with that before we try to differentiate. I'm just going to rewrite this first one slightly differently. X over 5 is the same as 1/5 of x. 1 over x squared is the same as x to the negative 2. Now I'm in a situation where I can differentiate. So I differentiate each term in turn. 1/5 of x differentiates to 1/5. X to the negative 2 differentiates to negative 2x to the negative 3. I'm going to tidy it up by removing that negative indus. So it's 1/5 minus 2 over x cubed. Okay, example 4, and we're still on page 5. Here we're asked to differentiate x to the power of 4 minus 3x squared all over 5x. Now I've got a sum on the top, but I've got an x on the bottom, and I need to somehow distribute that. What I'm going to do is I'm going to look at this fraction and say all of this on the top needs to be divided by 5x. So the first thing I'm going to do is separate them both and divide each term in turn by 5x. So I've got x to the power of 4 divided by 5x minus 3x squared divided by 5x. Now I can use my indus rules. Remember, x where there's no power there is to the power of 1. When I'm dividing, the indus rule tells me that I subtract the powers. So I'm going to write it with the coefficients outside. So here on the top I've got 1, on the bottom I've got 5. So I'm going to take out the fifth. I've got x to the power of 4 over x to the power of 1, so it's 4 take away 1 is x cubed. Again, I'm going to take out the constant, so minus 3/5 of x squared divided by x to the power of 1. 2 take away 1 is 1, so it's 3/5 of x. Again, be careful because we haven't differentiated yet. But we are now in the situation where we can just follow the rules, multiply by the power. So 3 times a fifth is 3/5. Reduce the power by 1, it's x squared. Multiply by the power, 1 times 3/5 is negative 3/5. Reduce the power by 1, that's x to the power of 0, which is just 1. Okay, example number 5. We've got x cubed plus 3x squared minus 6x all divided by the square root of x. Similar to the last question, we're going to separate it and we're going to divide each term by the square root of x, but I'm going to be rewriting that as x to the power of a half because I know that I need to remove the root before I can differentiate. So this is the same as x cubed divided by x to the power of a half plus 3x squared divided by x to the power of a half minus 6x divided by x to the power of a half. Same as before, if there's a coefficient, pull it out. If not, we're just doing a subtraction here. So I've got 3, take away a half. Well, 3 is 6 halves. If I take away 1 half, it leaves me 5 halves. You never do these powers as a mixed number. Plus, coefficient is 3. I've got x squared divided by x to the power of a half. So I'm going to subtract the powers. 2 is 4 halves. Take away 1 half is 3 halves. Whoops. Again, I'm going to take out the coefficient of 6. I've got x to the power of 1 over x to the power of a half here. 1 take away a half is a half. So 6x to the power of a half. Now again, it's tempting here to think you've done all the work, but we've not actually differentiated yet. So we're going to do each term in turn, multiply by the power, reduce the power by 1. 5 halves, this is going to be 5 halves of x. 5 halves take away 1, which is 2 halves, is 3 halves. 3 halves times 3 is 9 halves. X to the power of 3 halves take away 1 is 1 half. Negative 6 times a half is negative 3. X 1 less than a half is negative a half. So I've differentiated. Now I'm going to tidy up by removing negative and fractional indices. Negatives mean that x is going to move to the denominator of the fraction. The fractional indices, the bottom number tells you the order of the root, the top number tells you the power. So this is the same as 5 root x cubed over 2 plus 9 root x over 2 minus 3 over the square root of x. Okay, so that's all the examples completed. Now let's just check what our key points were and see what questions we're ready to do. Okay, just a few questions for you to think about here. We can differentiate a what of terms by differentiating each term separately. Think about what we mentioned all through this lesson. How do these terms need to be rearranged? Or arranged rather. Number 2, if a function is given in factorised form, so it's given as a product, what do you need to do? Number 3, how do you deal with a function that's a quotient? So that was like example 4 that we just did. It's like a big fraction. Number 4, what is the derivative of any constant term? So that's a term that's just a number. There's no x involved in it. The basic skills that you needed to be confident in for today were your indus rules, how to add and subtract fractions and how to multiply fractions, and also how to multiply out brackets. Now you are ready for exercise 6G. Questions 1 to 6 are unit level, so everyone needs to be able to do these. Questions 7 to 27 are level C. Okay, that was quite a long lesson today and quite a lot to take in.